Hi guys, it's Miss McGann. I'm here to just share some terminology when it comes to expressions or solving equations. I know that I found some terms were tripping some people up, so I just wanted to clarify some of those. We're going to review these key terms here. So our first one we have is sum. So what is the sum? When they say, what is the sum of 2 and 5? Addition, right? So the sum would be an answer to an addition problem. When they ask about the difference, so they're like, what was the difference between 11 and 2? What do you think they're asking for? Yeah, you would do subtraction to figure out that. So sum is addition, difference is subtraction. You can see that in the camera. Product, what would product, like product would be the answer to a multiplication problem. Yes, multiplication. I do X for multiplication. I know a lot of times we have a dot, or sometimes you'll see multiplication problems with parentheses, 3 times 4, which is 12. But yes, so product means multiplication, and the inverse operation, the answer to a quotient, or like a quotient would be an answer to a division problem. Yes. And most of the time, as you're doing these expressions evaluations, you'll notice that the quotients mostly come across as like fractions. So you might have like 15 divided by 5. You would see it as written as a fraction, and that would be a division problem. What is a term? Like they've mentioned, combine like terms. What would that be? Okay, yes. So it could be a variable of some sort. Maybe it is, even exponents. We have some exponents in our terms. There will be coefficients with those, but sometimes it's just a number by itself, So terms are just those individual items that are either being added, subtracted, multiplied, or divided for our purposes. So you're going to be finding the sum, difference, product, or quotient between individual items. Those are called terms. And so when they're trying to tell you like, hey, combine like terms, they want you to put numbers, combine numbers or variables together that are in common. So for instance, this y is technically a 1y. When the variable by itself is a 1. That can be combined with 2y. Those are like terms. 15 and 3 and negative 8 are all like terms because they have no variables. So they can be combined together. They're all constants. I guess I should say constants too. But yeah, constants are numbers without variables. And what is a variable? It's a symbol to represent a number. Awesome. So symbol or a letter to represent a number. Rep a number. You can write represent. But yeah, so that's what a variable is. Lots of times we'll see X, which is why we tried getting rid of the X as our product symbol because it kind of got confusing. You'd see a Y, maybe an A or a B. Those are all variables. And when you do different equations, they'll use multiple variables because we may have multiple pieces in our formulas and our equations. And then last, distributive property. I've used this term multiple times, and I think sometimes people don't necessarily know what it means. So did want to clarify. For distributive property, that's when we have like a constant or a coefficient. Oh, I skipped over coefficient. So for distributive property, we'll say it was 3x plus 5. Distributive property means we are going to distribute. We are going to use that constant or that multiplier to all of our terms, right? So our terms, we have 2 terms here. We are multiplying our 3 to both of our terms. The coefficient is the number outside that it's multiplying. This would be a coefficient. Sometimes it's a 2 times y. That's what 2y is. It's 2 times y. Sometimes you'll see it on the outside of a parentheses, 3 times x plus 5. So coefficient is that multiplier piece. So if we have 3x, this is it. If we have 2z, which looks like 2, if we have 14a, those would be our coefficients. It's those numbers, those multipliers. And then our exponent sometimes can be construed. Exponent is those little numbers. So it's when we square or we cube a number. It's those little numbers next to our variables and next to our constants or coefficients as well. So if we have 2 squared, that would be our exponent. If we have 4 to the third, that would be our exponent. If we have g, it's like a goofy g to the 7th power, this is our exponent. It's that little number. And that tells us how many times we're multiplying the base. These individuals, 2, 4, and g, are bases. So I guess I should put base up here too. So our exponent is the little numbers. So hopefully these terms kind of helped you a little bit navigating through expressions and evaluations. But you guys got this. Let me know if you have any further questions, and have an awesome day.